Hello and welcome to the 11th video in the Introduction to R workshop series accompanying videos. These are coming from the QIMR Berghofer Statistics Unit. So I've talked about the QIMR Berghofer Statistics Unit before and the services we offer, where we are and how you can contact us. They're just all there again if you're interested. Hopefully before this video today, you've had some experience with R, you've gone to the workshops, you've seen some of the other videos, you've read through the booklet. This would be a very weird video for you to start with if you've done nothing else from us before. But yes, hopefully you've got R Studio installed. We will be using the WK2_15_ severe condition data for input.csv file today, just something a little bit later. So hopefully you know where that is saved and you can set your working directory to where that is. So today, we're not necessarily doing much data analysis or anything like that. We're looking at a little bit of some of the programming capabilities of R. Now, these are the type of programming capabilities that most languages can do. So you're talking your Python, your MATLAB, lots of different things can do these, lots of different languages can do these things, Stata and SAS as well. So these aren't things necessarily special to R, but these are things that you may not have come across before, and you may find them useful in your future work. So we're just going to show you how to do some of the brief skills in here today, and then you may end up using them later on. So what we're going to do is we're going to look at conditional statements, which we've looked at logic before, so we're going to see how else we can apply logic with our conditional statements. And then we're going to look at for loops. And for loops can be the starting point where you might go into stuff like parallel computing and making your code more efficient. So to start with, if statements. So if statements are conditional instructions. So basically, if you've got in your code, say you're not just entering code as you go, instruction, result. So you've written a set of code that you're going to apply again and again, and you've got a set of instructions that you only want to be done if a conditional statement or a logical statement is true. So it's basically saying, if this is true, then do these steps. So what I'll do is I'll jump across to R. So it's if statements. So what I'm going to do is I'm going to make a data vector. So using the C function, I'm going to make this object data. That's a vector of 6 numbers. Now, the big thing if you've done, as I'm sure you'll be aware, if you've done other computing languages before, is that the syntax can often be a little bit different between each language. So the syntax for if statements in R is we've got if, then we have brackets where our logical condition is in. So that bracket comes right after if, we've got our logical condition there, and we have these curly braces that contain all the instructions for the if statement. Generally by default, RStudio will put all your commands in a tab of where you were previously. So if I enter down here, it moves up there. So basically this statement here, this code is saying, if the length of the data vector that I've called data is greater than or equal to 4, calculate the mean. Realistically, what it's saying is, I want to calculate the mean of the vector of data that I've called data, but if the vector is small, less than 4 elements, I don't really want to calculate the mean for it. So this logical condition here is the conditional statement. So the length of data is 6 because I put 6 numbers in there. That means that this statement here is true because 6 is greater than 4. So when I run that, it calculates the mean for me and outputs the mean as 2.83 recurring. If I change that logical statement to something like 10 and ran this code, nothing would happen because I would say, all right, this conditional statement is false because the length is not greater than or equal to 10. And nothing would happen. So it wouldn't even evaluate the lines of code within the curly braces. So say what I do here, data is now only 3 elements long, which means when I run this line of code, nothing will happen. Now, if I go back here with back to my 6 elements vector, what I've got now is I've got code that I'm calculating many things for my vector. Again, there's the logical condition that length of data has to be greater than 4. But when I run this line of code, get it here, I only get one answer at the end. I only get 2.5, which is actually the median. So basically what's happening there is within the if statement, all of those things, all of those functions, the mean, the variance, the sum are being evaluated. But only the last one will be printed to the screen. So this is kind of the difference between just doing normal line by line code and starting to put things in stuff like if statements. That just because you evaluate doesn't mean necessarily the outcome will come to the screen. So this is where things like the print function really comes in handy, because the print function will always force it to be printed to the screen, like we have here. So there I have the mean, the variance, the sum, and the median all being printed to the screen. So in earlier videos where we were like, why do we have the print function if we can just print things without using the print function? This is examples where that the print function can be useful in terms of forcing things to be printed to the screen where otherwise they might not be. Now, of course, your conditional statement can be as long as you want. So I've already got length of data is greater or equal to 4, but I can add anything I want there. So basically, this logical statement is saying if the length is greater than or equal to 4, and there is not any instances of triple 9 being in the data or 0 being in the data, print it. Which, because there isn't, it doesn't happen. But of course, if I were to change that and have a 0 in there, this statement here would now be false because this function is false. So if I run this line of code, nothing happens. If you're not following some of the logic I'm using here, I encourage you to go back to the previous videos where we talked about logic and how ands, annies, and nots work. But essentially, within these round brackets, we can make any logical statement that can be evaluated to produce a true or a false. And then depending if that value is true or false is to whether the rest of these lines of code in the curly braces run. So if the statement inside the round brackets is true, the things inside the curly braces is evaluated. If it's not true, if it's false, nothing gets evaluated. And that is your if statement. Now, to expand on that, we can also have an if-else statement. So this is a separate set of instructions to be processed if the logical statement is false. So remember, the outcome of that logical statement can only be true or false. So if the logical statement is true, the first set of instructions in the curly braces will be evaluated. However, if it's false, we can add a second set of instructions after the else command that will be evaluated instead. Now, only one of those sets of instructions can be evaluated because the conditional statement can only be true or false. They can't both be evaluated because that would require a statement to be true and false, which is impossible. A Boolean logical statement can only be true or false. So this is a way where we could say, if this condition is met, run this set of instructions. Otherwise, these are the instructions to run. So it's like a backup set of instructions in a way. So let's jump across to R to see how it works in practice. If I haven't mentioned this before, in this version of RStudio that I'm using, if a line of comments ends in 4 comments, it turns that line into like a collapsible heading. Just in case you haven't seen me do that before and are wondering how I'm doing that, it can be a bit of a useful thing if you've got a large set of code that you want to break up into pieces. Okay, so this time I'm going to be using a vector called data that's only 3 elements long. So my if statement is saying if the length of data is greater than or equal to 4 elements, so if there's at least 4 data points, I want to calculate the mean of my data. However, my condition of being at least 4 is so that I have like at least a decent amount of data to calculate a mean for. Because if it's only 3 points, I'm not really bothered about finding a mean. So instead, when I've got my else condition, which will only be evaluated if that condition is false, what it's doing is printing the character statement, not enough data, and then printing the data there as well so I can see what it is. So I don't have to highlight the code. If I've just got my cursor on the first line, so in that if statement, and go Control Enter, it runs the entire code for me. And I can see here that it's failed the conditional statement in the if line, which means it's jumped to the else bit and run the lines of code that tell me it's not enough data, and this is the data vector that I have there. So this can be useful if you have a set of line, so you've got a set of instructions you want to do if a condition is met, but then if that condition is not met, this is an alternate set of instructions you want to run. I'm aware I may be going a little bit quickly here. I think that's just the nature of the fact that it's a video. Normally we'd very much encourage you to come to the workshops and we can take our time with this to make sure you understand and explain, you can ask questions. So if I am going too fast for you, by all means, pause the video, go back over a few things and go back to the booklet. Okay, the next one, making this a little bit more complicated, is the else if part of the conditional statements. So you can add more conditional logic statements to the else set of instructions, and you can make a sequence of possible instructions. So basically what that means is you've got your first set of instructions you can do if a condition is met. And if that condition is met, rather than just having one set of backup instructions or one set of alternative instructions, you could have many, and you can add conditional statements to say which of those alternate sets of instructions you may want to do. So essentially this reads as, if the first logical statement is true, this is the set of instructions I want you to do. If it's not true, I want you to do something else. I want you to see if this logical statement is true, and if so, I want you to do this second set of instructions. And you can keep adding those things, so you can have multiple, you can have 3, 10, 100 lines. Wouldn't necessarily encourage 100 of them. There'd be other better ways to do things then. But you can just keep adding them to be like, okay, that condition isn't true, now try this condition. And then finally, you can end with, if all other conditions are failed, this is the final set of instructions I might want you to do. So let's jump across to RStudio and see what's in the else if statements. So my data is still only 3 lines long. So what I've got here is, if my length of data is greater than or equal to 4, I'll calculate the mean of the data. Else if by that point, if its condition has failed, it means I have less than 4 points of data. Now, I've got 2 alternatives here. If the length of my data is 0, I want to print the character value, you have no data, letting me know that I actually has have no data in general rather than just not enough data. And then finally, if the length of the data is not 4 or more and it's not 0, then I would print the not enough data line and print the data to let me see it. So I'm going to have my cursor at the top there, Control Enter. So that's what I get out. If I changed data to an empty vector and ran it, it would tell me that I have no data, in a very rude way, by the way, very mean of it. And then of course, I could go back to this data size and run that here. Yeah. And it would calculate the mean. So that's basically just showing that depending on the conditional statement as to which set of instructions you want it to run. And you can keep adding more else ifs. One thing to note that here in R, else and if are separate words when you set it up like this. Some other languages might put them together, but the syntax for this is essentially if round brackets with my logical statement in it, curly braces, then else space if round brackets with logical statement, curly braces. And you can keep adding more else space ifs, and then finally get your else and curly braces at the end. You don't need to end on an else. You can make an if and an else if, and then also an if else if logical statement without having a final else. Essentially what that would mean is that there might be cases where if all of your logical conditions or conditional statements fail and they're all false, just nothing will happen then. There'll be no else to capture that situation, and then just nothing will happen. So sometimes it can be good to have an else, and then just say none of the conditions were met, so nothing's happening. It might be useful depending on what your situation and why you're using if and else if statements. Okay. Let's go back here. Okay, so that's if and else if statements. Again, apologies if this video is moving a bit too quickly for you, or maybe it's fine. Definitely encourage you to practice with these, look at the activities and examples in the booklet, and hopefully come to a workshop if you can. Now we are going to talk briefly about the for loop. Now, for loop is a fairly basic concept in computer programming or numerical programming. It's basically you're repeating a set of instructions a number of times. You might be repeating sets of instructions on different things each time, but you know how many times this set of instructions is going to be done. And so you can set up code to say, for this many times, do this set of instructions. So it's just a way to quickly say, this is a set of instructions, I'm going to do it a number of times rather than having to write those instructions out every time. So let's jump across to R. So for this, I'm going to be using the scdata command. Oh, sorry, I'm going to be using that severe condition data set that we've used previously, or that when you're using that severe condition data set for this, I'm going to call it in and call it scdata. Just to practice a few things on. So what I've got here, I'm first just going to look at the basic principles of a for loop. So we're using the seek function, so that's seq. I'm making this vector here of 2, 4, 6, 8, 10. And I'm basically going to say for each number in that line of code, print the square of that number. So what I've got here is 4, I in that vector I just made, curly braces, line of code is print I squared, and then end curly braces. So if I run that line of code, I can see here it's gone through, and each time it's gone printed the square number. So 2 squared is 4, 4 squared is 16, 6 squared is 36, etc. up to 10 squared. So that's the syntax of a for loop in R. It's for round bracket, some variable. It doesn't have to be I. It can be J, it can be K, it can be whatever word or name you wanted. I think there are a few exceptions that some, like, for example, forbidden characters. And there are some things you perhaps shouldn't use. I is the most common generally, but for some looping variable in, and then you've got a thing to loop over. So this might be a sequence from 1 to 20. You can set it up that way. One thing that R does very well is that you can loop over vectors like I've done here. So rather than just saying 1 to 10, I can say this specific set of vectors or this vector of characters and use those inputs as my input for my looping variable. R is very generous with what you can use to loop over, but essentially what I'm doing is for each element in this vector, I'm going to do the set of commands. And basically each time I go into a new loop, so I first do a set of commands when I is 2, I then do the same set of commands in the curly braces when I is 4, and that's how things change. So if you're wanting your set of commands to do something let me rephrase this. If you want your set of commands to do the same instructions but on a slightly different thing each time, like I'm doing here, your looping variable is how you decide what you do those set of instructions on. So for example, I want to print square numbers. So this is what my code is here. I'm printing, and I've got the squaring thing happening there as well. But I also want to do that on different numbers each time, which is why I use I and loop over different values by saying, hey, I'm going to use my looping variable I. These are the values I want to loop over, and this is my set of instructions I want to apply to those values. So as I goes from 2 to 4 to 6 to 8 to 10, the same set of instructions is applied to a different value each time, giving me my different square numbers. Now, how could this be useful? Let's look at what scdata is. It's just a small little data set where for each month, there's a total number of cases and a number of severe cases for the month. Now, this is just a pure example of when you might be wanting to use this type of concept. But basically what I'm saying what I'm going to want to do is I want to make it really simple for myself to take this information, put it in a sentence, and then put it in a report perhaps, where I combine those different information in different ways. Of course, there are other ways you could do this, and I'm just doing this as a really quick example to show how we might want to do it. So what I'm going to do here is I'm going to set up my for loop. I'm going to make up this variable mon, and that's going to be my looping variable. And then the values or vector I'm going to loop over is the month variable of scdata. So the month variable is this vector here, which is a factor variable, which is fine, that has January, February, March, April, etc. down to December. So basically, if I for loop over this the way I've set it up, mon is going to take the value Jan, then Feb, then Mar, then April, then May, June, then Jul, and go and loop through each of the values in that vector that I give it. And each time it changes values, it'll run these sets of instructions. And in these sets of instructions, I've made the instructions dependent on mon. So first of all, I'm going to make this variable sev, which is going to be the severe cases from a C data set when month is equivalent to mon. So I'm just doing that with my square bracket filtering method, where I've got my severe vector there. And I'm saying when the month variable is equivalent to mon. And I know it should be equivalent at some point because mon is going over all the values within month. I'm then doing the same for the total by getting the total value that matches up with for the month that equals mon. And then calculating a percentage. So the percentage of total that is severe, and also then rounding that. And then I'm printing that information to the screen. I'm also using the paste function. Paste is like concatenate in Excel or different other functions in different languages. But basically, I've got text or a character value, comma, some variable, text, comma, variable, comma, and I'm putting them all together. And then paste will combine those character values and the variable values that I'm creating, and then print will print it to a screen. So what I'm going to do, I'm going to run this here, and it's telling me for each month, it's giving me the sentence in the month of Jan, there was 120 total cases of the condition, of which 80 bracket 66.7 were severe. So just to recap what I've done, I want to get this information out for each month. I want to make this sentence, I want to print it to a screen, and then I'm probably going to copy paste it to a report. And because I'm going to do that so many times, rather than write out the code each time, I'm going to write some code that gets the set of instructions that are going to be repeated. And for that, that's going to be getting the number of severe and total out of the data set, calculating the percentage, and then also writing that script, writing that sentence using paste, so putting those values into the text and then printing it to the screen. And so once I get those 4 things, I'm going to say, okay, I'm going to do these 4 things 12 times, 1 time for each month. So I'm going to set my for loop to go through each of the values of the month in my data set. Now, of course, I'm sure you're thinking there will be easier ways to do this exact same task. Absolutely, there would be. This is just an example of how you could use a for loop, where you have your set of instructions that you want to do, and you know you want to do them a number of times. So you only have to write them out once, and then use the for loop to say, this is how many times I want you to do this set of instructions, and this is what I want you to do them on. And that's all for this video. Please go through the examples and activities in the booklet. And just remember, the best way to learn R is by doing R.